Hi everyone, today we're going to be looking at quadratic models. But before we start looking at a few examples, I just wanted to go through some of the basics. So when we use the quadratic formula, you can see this is the graph that you'll get. This parabola opens up and can be classified as concave. This would be a positive a value. And remember that we have both an x and y intercept, and then you also have the turning point or vertex here as well. And sometimes that, for this particular graph, would be your minimum point, whereas if it's a negative a value, this would be your maximum point. So just a few things to remember as we go through the examples. So in this question, it says a landscaper has 20 metres of edging with which to construct a rectangular garden bed. He wishes to construct the garden that has the greatest area. If one side of the garden bed is 2 metres, calculate the length of the other side. So if we have a rectangle, we know that, for example, this width and this width must equal each other, and then that this length and this length must equal each other. So we know that if it's 20 metres, one length and one width, so one length and one width, must equal 10, because the total altogether, if we do the perimeter, which is width plus length equals 20, because that's the total. He has 20 metres altogether. So what we want to do is calculate the length of the other side. So if we know that one length plus one width equals 10, and we know that one of these sides, so one of these here, so width plus length equals 10, we know that has to be for the total to equal 20. And we're saying that one of them equals 2, which means that the other must equal 8. So we know that the other length here equals 8 meters. And now it's asking, so the second part of this is to find the area of the garden if we know these lengths. So we know that the formula for area is length times width. And if we just use this here, we know that we have length as 8 and we have width as 2, and so the area of this particular sort of dimensions of the rectangle would equal 16 metres squared. Okay. Part B says if one side of the garden bed is x metres, find an expression for the length of the other side. So just like before where we said length plus width has to equal 10. So if we just go back here, it has to equal 10 because our total has to equal 20. Okay? So if length plus width equals 10, and we're saying one of those sides equals x, then we could write the expression of x plus w equals 10. And that should then tell us what the length of the other side is. However, it's trying to say that we need to have the expression in terms of. So all we're going to do now is we're going to try and find, or we're trying to reorganize our algebraic equation so that w is on its own. So if we had to do that, what we're going to do is we're going to take our x to the other side. So then it'll be w equals 10 minus x. So now, if we needed to ever find what the other length is, we can do that pretty easily. So using this now, it says we need to find the area of this garden bed, and we're going to symbolize area as A. So we know area is length times width. Now, in this top equation here, we had length as x, and we had width as this equation here. So now we've got 10 minus x. So all we're going to do now is simplify. So what we're going to do is expand our brackets. So x times 10 is 10x, and we've got a subtraction here, so minus, and then x times x is x squared. And as you can see here, this formula is actually a quadratic function. So what you do now is you draw the graph a equals 10x minus x squared, and there's a number of ways to do that. One is to do a table of values, which you've got here, and all I've done is substitute all the x values into the formula and got the y values, or I should say the a values, and then you can plot those and draw out the graph, or what I did was I used the online tool. From the graph, we're then going to find the maximum area of the rectangular garden bed and its dimensions. So if you remember when we first looked at the different types of quadratic graphs, you knew that this point here is our maximum point. So if our maximum turning point is 5 and 25, that means that the maximum area is 25, because that's our maximum. So if you look here, it's 25. So maximum area is 25 meters squared. So that means that if we had to then, from that, try and work out what our dimensions were, and you know that area is length times width, well, we think about two factors that multiply 25, well, that would be 5 and 5. So the dimensions of that rectangle would be 5 by 5, when in fact that would be more of a square. But that's what our function tells us, and we can read that off our graph as well as use our algebraic equation to do so. Here's another example. A bungee jumper dives from a platform from a bridge over a river. The height, h meters, above the ground after t seconds in the air is given by this function. So what I've done is I've actually graphed this in the online tool, just so that we can already have some values straight away. So using the graph here, says what will the jumper's height be after 1 second? So if we have a quick look, we should be able to see that we need to find the h value when t equals 1. So if we have a look here, we can see that on our graph, and we can use our graph to do that. And if I read from my graph, h equals 1, and then that should give me, if t equals 1, and if I use my graph, I can actually, on the online tool, place my cursor on there, and h actually equals 144 meters. Now, if you hand drew that graph and you're not sure about the accuracy, what you would do is you would use this formula, and you would place in where t equals 1, and you should get 144 as the answer. So from what height did the bungee jumper initially jump? So for this question, what we need to do, so remember initial, and we talked about this in another video. Whenever we talk about initial, it's always when time equals 0, because that's the starting point. So what we're going to do is, you can either, again, substitute that back to the original formula, or if I just look on my graph where t equals 0, and this is my initial point here, we can see that the height is 160 meters above the ground, okay, because that's the starting point. There's no such thing as negative time, so we know that all of this is not relevant. So this here is where he starts from in terms of his jump. C, how far long was the jumper in the air for? So that means at how long a time did he stay in the air? So if we have a look at our graph, we want to be able to see where the graph actually intersects with the t-axis. So if we go along here, so where h equals 0, we can see that here t equals 3.162. Okay, and that's just a point that was on the graph, and that's my t-intersect. So the bungee jumper was in the air for 3.162 seconds. So in this example, we've been able to use the graph quite clearly to answer them, but again, at any point, you'd be able to substitute these values back into the formula to be able to calculate them.